Hi, and welcome to our next level 3 trigonometric graphs video. We're now talking about a horizontal shift for our 3 trig graphs, sine, cosine, and tangent. So going back to our last couple of videos, we've talked about the amplitude, the number out the front of the sine, cosine, or tan. Be mindful if the number out the front is negative, it keeps the same amplitude but just is a reflection. And be mindful that if we have a number d at the end where we plus or subtract, the whole graph moves up and down. So in this example, the whole graph has come down 1 square and it's got an amplitude of 2.5 squares. Right, let's get straight into our first example for this horizontal shift, is what we're going to chat about in this video. And I'm going back to degrees for this example. So y is equal to sine bracket x minus 60 degrees. Now, here's what the graph looks like. Let me just draw in what the normal y equal to sine x graph looks like in orange. Now, hopefully you've figured out that it's just moving one graph sideways. So I'm going to take the sine x graph and I'm going to take this peak value here and move it 2 squares to the right. Now, 2 squares represents 60 degrees because each square we're counting up 30, 60, 90. So each square is 30. So 2 squares is 60 degrees. So we're moving the sine x graph 60 degrees to the right to get to our new graph, y equal to sine bracket x minus 60 degrees. Now, this is what the 60 degrees inside the brackets does. When we plus or minus a number inside brackets, we move the graph sideways. But be mindful, it's a minus 60 degrees, but we've moved the graph to the right. So it's the opposite of what we see in the brackets. If we see a minus 60, we move to the right 60 degrees. If we see a plus 60, we'd move it to the left 60 degrees. All right, let's try example 2 and come back to radians. So here's our graph, y equal to cosine bracket x plus pi over 2. Well, here's what the graph looks like. Now underneath, I'm just going to draw the normal in orange, y equal to cosine x graph. Now, can you see that the cosine graph has moved 3 squares to the left, and 3 squares represents pi over 2 radians. So we've moved it pi over 2 radians to the left. That's what this plus pi over 2 in brackets does. We move it to the left because it's a plus pi over 2. Now, we could have moved it to the right by 3 pi over 2, and we could have written down this equation instead. Cosine bracket x minus, because if we put a minus inside the brackets, we move to the right 3 pi over 2. So both of those equations represent the new graph, but one has been shifted to the left, one's been shifted to the right. All right, let's have a quick look at this idea. Here's our sine graph, y equal to sine x. And here's our cosine graph, y equal to cosine x. And hopefully you can see that they're just one graph is shifted to the left or right. So I'm going to take my cosine graph and move it to the right by pi over 2 radians. So I'm going to write down y equal to sine x, which is equal to cosine bracket x minus pi over 2. Now that's a shift of pi over 2 to the right. Remember, if I put a minus pi over 2, we're moving the graph to the right pi over 2 radians. So the cosine of x minus pi over 2 graph is the same as the sine graph. In physics, we often refer to these graphs as being out of phase. In other words, the same graph just shifted along out of phase. Right, here's example 3. Y equal to 2 cos x plus pi over 2 in brackets plus 1. So the whole graph is up 1 square. It's got an amplitude of 2. And the whole graph has moved pi over 2 to the left because it's a plus pi over 2. Okay, now we're at the stage where we've talked about the amplitude, the vertical shift, and now today the horizontal shift. Thanks for watching.